Okay, a little bit of quick work on the definition of a derivative function, and what you're going to find out later is that you don't like me because later because you just won't like me. No, because later you're going to find out that this is all unnecessary, and there's some huge math nerd out there who's going, man, it's the most necessary thing in the world, except for math nerds don't talk that way, usually. So this is a proof to me. This is absolutely the truth. But we'll find later that this is not used as often as one might think. So what happens in the beginning of calculus is people buy into this and they're like, oh my God. And then they find out 2 sections later that we're doing something different. I mean, we have to be able to prove everything with this. So let me say that. And if you're going out to Calc 3, which is a really cool class, then you're going to really need to kind of have this stuff in mind. But for the rest of you who are going to kind of do Calc 1 and stop, well, you'll see. So let's take a look at this. We're asked to find this derivative. So let's say that f of x is equal to x cubed minus x. And what you're going to find out later that this is a really easy way to do this, and we're going to find out that the derivative it should be 3x squared minus 1. And later when you discover how I did this, you're going to hate the fact that you were forced to do this, but you have to be able to do it. So let's actually do this. So what we're going to do is just force our way through this, and we're just going to fill in the blanks here, and we're going to fill in the blanks to here. And initially we are going to say that f prime at x is equal to the limit as h goes to 0 of, so f of x plus h. Well, f of x plus h is x plus h. This f means what's happening to our function. In this case, our function is being cubed. So cubed. So far, so good. And then minus x plus h, minus x plus h, because that's the other part that's happening here. So all I did was every place I found an x, I filled it in with x plus h. It's the change. So it's the change in x. Minus, and it says to take out this whole f of x thing here. So this f of x here is me taking out the whole thing, which was x cubed minus x all over h, which this is new. Not new. This is different form than I usually write in. I usually write in change of x form because I think it's more descriptive. But for this example, I decided I'd just use a different variation. Now what we have to do is we have to expand this out, and you really need to know your binomial expansion. I'm going to go ahead and do this, but I'm not going to spend the time doing this algebra. Your professors are not going to expect that they should have to wait for you to do that. So I'm going to do my binomial expansion, and I know I'm going to get 4 terms here, and the first one is going to be x cubed, and then I'm going to get, combined, I'm going to get 3x squared times, 3x squared h, and then plus 3x h squared, and if you know binomial expansion, it makes sense why it's coming out this way, h cubed minus, and I'm just distributing now here to here, minus x minus h, and now I'm going to distribute this part to negative x cubed plus x all over h. And here, this is really important to me that you get this, that here you don't have to write this again, but you have to write this. And so you want to write the limit as h approaches 0. And if you can see, just for sake of an argument, the problem right now is we can't let h go to 0, because if h went to 0, this would be undefined, wouldn't it? So we can't do that. What we're looking for as soon as possible is to let that thing go to 0. So I'm going to just do some work here. First thing I'm going to do is cancel like terms. So let's take a quick look and see what our like terms are. And we have an x cubed and a negative x cubed. We have an x, and we have a negative x and a positive x, don't we? And right, okay, so good. Now what I'm hoping you're noticing, and it's huge to us, this is big time that we're really looking for. We have h in this term, 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 and look, we have this h down here. So what I'm going to do is, this is huge, factor out h, right? Our change in x is our h value. So I'm going to factor this out. I'm going to rewrite again because your professor really is looking for this form. So we're going to get h times 3x squared plus 3xh plus h squared minus 1. Now, if you're confused at all, take a look. h times this mess gives me this mess back, doesn't it? H times this gives me this back, doesn't it? H times h squared gives me my h cubed, and h times -1 gives me my negative h back, doesn't it? Now you're wondering, well, why the hell would I do that? Why would I care? Well, I told you that in this example up here, in this part of the problem here, we couldn't let h go to 0. But if we have h over h as a factor, then we can cancel this. So h over h is 1. So we end up with this. Now let me ask you, what would happen? What would happen if h went to 0? So we're going to take the limit. We're going to take the limit. So h is equal to 0. So we'd have 3x, there's no h there, right? Plus 3x times 0 plus 0 squared minus 1. That's perfectly defined, isn't it? And when we simplify that, we find out that the derivative that we are looking for, the slope of this function at any given x value, is 3 times the x value squared minus 1. So there's the proof of our derivative. Now, remember I told you there was a really easy way to do it. And the way that I did this, just to show you really quickly, is I did 3 times 1 is 3. I decremented the exponent, so 3 minus 1 is 2. I did the same thing here. This is to the first power. 1 times -1 is -1. And then x to the first minus 1 is x to the 0. We know x to the 0 is 1. So that's the little trick, if you will. It's called the power rule. But your professor will not appreciate your use of that rule when he or she is trying to teach you this process of proving your derivatives. So got to do what you're asked to do. Hey, thanks for watching. I really do appreciate it. If you're not already subscribed, please subscribe. And honestly, your comments are welcome. I look forward to them. Thanks.